Hey guys, in this video we're doing lesson 5.10, which is on projectile motion, and this is the last lesson of the unit. So projectile motion, these questions are all about like throwing a ball in the air or launching a rocket, something that actually causes a parabola because it goes up, and as time increases it comes back down. And so all of these questions are going to ask sort of the same things. So we're going to have some word problems, but I'm going to give you some guidance on if it asks this, okay, this is what you find. This is what you do. So let's just talk about what the graphs look like. So along the x-axis, this is our time. Time in seconds. So 1 second, 2, 3, 4, 5 seconds. And along the y-axis, this is our height, and normally in feet. Okay. So if you were to throw a ball into the air, at 0 seconds, you're not throwing it, so it's down at the ground. But as you throw it and time goes on, it gets higher and higher and higher and higher. And then it comes back down, 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 down. Just like that. So we get like a parabola. And some of the things that you're going to be asked for. One of them. What is the height at just some seconds? Like, what is the height at 1 second? Well, at 1 second, it'd be about 1 feet. So if you're asked this, you just plug in the number for x. Those are the quickest and easiest ones that you will be asked. Then it might say, what is the maximum height? Ooh, the maximum height. That is like, what is the highest the ball got? That is your vertex. And so the x value of your vertex, that's the number of seconds it took to get there. So like, if this is your maximum height, the x value is like, well, it took about 3.5 seconds to get to the top. The y value is the actual height. And remember, vertex, that's the negative b over 2a. Okay. Then the other thing that it might ask is, when does it hit the ground? So you're looking for this point. When it hits the ground, the height is 0. These are your x-intercepts. And you're always going to need to use the quadratic formula for those. All right, so let's do an example. A soccer ball is kicked from the ground, and it tells us the velocity. So that's important for these. If you kick it harder and faster, it's going to go higher than if you barely kick it. So the velocity is 90, and it gives us the equation. So we don't have to come up with the equation. That gives it to us. So number 1 says, how many seconds will it take for the ball to reach its maximum height? So remember, the maximum height, I told you, that comes from the vertex. And because we want the number of seconds for the vertex, we're only finding the x value of the vertex. So we are using the formula negative b over 2a. So look at your formula. Your b value is 90. So this would be negative 90 over 2 times negative 16. And we get 2.8 seconds. Then it says, okay, well, what is the maximum height? What is that height of the ball at the top? So that would be the y value of the vertex. So when we're finding the y value, we plug in 2.8. So we take the x value and plug it back in to find the y. Okay? And so this is where I would use the store function, 2.8, store that as x, and then we can just type in negative 16, just use x. X squared plus 90x. And we get 126.56 feet. So that ball, or the soccer ball, went extremely high. I almost think it was like a robot being kicking it. I don't know if somebody could kick a soccer ball that high. Maybe they could. I don't know. All right, next one. An apple is launched directly upward at 64 feet per second from a platform that's 80 feet high. And here's the equation. What is the apple's height after 3 seconds? So this is the one where we just plug in 3. I will use the store function again. 3, store it as x. So I will remind you, 3, store it as x. And then hit enter. And then you type in the equation. So 3, store it as x, hit enter, and then we have negative 16 x squared. Now actually I made a mistake here. This really should say 64. So plus 64x plus 80. And we get 128 feet. All right, so number 4, a toy rocket is launched directly upward from a 12-foot platform with a velocity of 128 feet per second. And it gives us the equation. How long will it take the rocket to reach the ground? Remember, this is where I said you're going to have to do quadratic formula. Now, when you get this, you will most likely get a negative number and a positive number. When you do it once, it'll be a negative. Another time will be a positive. We only care about the positive number. All right, so that quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. And remember, we always put parentheses around every letter. So, negative, my b is 128. Plus or minus the square root of b squared minus 4a times 12 all over 2 times negative 16. All right, so in your calculator, remember, alpha y equals will give you your fraction. And then we're going to type it in exactly as it looks. I didn't write in any times buttons. We're going to use the parentheses just like it is. Negative parentheses 128. We have to do a plus first. Or you can do either one first, but you just can't do them at the same time. Plus the square root. In parentheses, I put 128. Close the parentheses, squared. Minus 4 times negative 16 times 12 all over 2 times negative 16. And this one we get negative 0.09. Remember, I told you if it's negative, just ignore it. Let's go back to our formula and change the plus to a minus. And when I do that, I get 8.09. And that was the number of seconds that it took to reach the ground. I'm actually going to stop there, and those are the only 4 examples. You will probably see 1 or 2 questions on the test, and they will be just like these examples. So when you get to those, you just look back to see what we did, and if you follow those same steps, then you'll be okay. If you have any questions, let me know. Have a great day.